So here's the problem, and the problem is for stoichiometry and limiting reactants, percent yield, that sort of thing. So the question is, if you have 200 grams of iron bromide and 300 grams of sulfuric acid, let me fill in some gaps here. Fe2O4 All right, you're missing a couple of things on your screenshot, just so you know, for those of you that are following along in class. Product FeSO in parentheses should be Fe2SO4 and then a 3 on the outside of the parentheses. So if you're right on, that's the way it should look. All right, so which is the limiting reactant? So the question, you have 200 grams of iron 3 bromide, 300 of sulfuric acid, which is the limiter. The steps for that are, first of all, before you start, that's why it's labeled step 0, before you start, you have to balance the equation. Well, this is already pretty balanced. We already put the coefficients in. We have a 2, 3, 1, 6, so we're in good shape. Then we're going to convert given values to moles, remembering that if we have grams, we convert to moles, grams to moles, right, from your conversion table. So you had moles in the middle. You had out here atom molecule or whatever particles. Then yes, and then over here you had grams. And if we were, oh, let me make sure that's a straight line. There we go. If we're going out this way, we're grams. And remember, if we're going away from moles, we're multiplied by the mass. And over here, we're multiplying by hold on, settle down, pencil. 6.02 times 10 to the 23rd. And remembering down here, we will be multiplying by 22 liters of ideal gas at standard temperature pressure. Okay, so that's when you're leaving moles and you're away from it, we're multiplying. When you're returning to it, we are dividing. So right here in this scenario, we're going to converting from grams to moles, and these we're going to divide by molar mass. Okay, and so same thing here. If you had atoms or molecules or whatever, and you're head back into mole, then we're going to divide by 6.02 times the 23rd. And down here, and I'm going to try this and we'll see if it lets me. This would be liters. That's perfect. Come on. Liters of gas. STP, and then that's multiplied. If we're going away from moles, multiplying. If we're going towards mole, dividing. So just make sure we're there. Okay. So all right, my pen is not responding, so I don't know what to tell you. So I'm just going to erase this stuff down here just for the conversion. I want to make sure you see that that's how the conversion works. So we're going to take our grams, divide by molar mass, and work that at angle. So we got 200 grams of FeBr3. Going to do here, it's acting all crazy and stupid, so hopefully it gets caught up and we get back to normal. Okay, so 200 grams alright, I don't know why it's not letting me do that, but whatever. 200 grams of FeBr3. So Fe has a molar mass of 55.85 grams per mole. And then Br let's go. This is a little frustrating. Trying to get this thing to line up. Come on. Okay, so Br has a molar mass of 7.9. I mean, usually they don't do this, but 79.9. Sorry about that. Not 9. That's an odd looking thing. 79.9 per mole. And there are 3 of those, so 3 times 80 is 240, 55 is 295.85. So 200 grams divided by 295.85 grams per mole. We'll cancel out the grams, leave us with moles. So 200 divided by 295.85 is 295.85 is 677. Change colors here just so you see that this is 0.676 moles. Okay, 0.667 moles. So grams divided by molar mass, I got 200 grams divided by 295.85, 0.6766 moles. Okay, so that's our first. Step is 0 step is balance. Step 1 is convert the given values to moles. That's how much we have. And over here, with 300 grams of 2SO4. So 300 grams, and then an H2SO4. H is equal to 1 and the 2 of them, so that's equal to 2. S, since there's only one of 32.066 grams per mole. And O is 16 times 4, which is equal to 64 grams per mole. So a total of 64 and 32 is 96, and 2 is 98, 98.066 grams per mole. So we're at 300 grams divided by 98.066 grams per mole. Decimal, and so it's equal to how many moles? So 300 divided by 88.066, 3.06. So this has to be 3.0 moles. 3.06 moles. And then that's how much you have here. So 3.06 moles. This is how much you have. And then we've done that. We've converted all of our given moles, and we're good. Now what we want to do is apply the mole ratio. So in order to find out which is the limiting reagent, we got to apply mole ratios. You know how much we have? We have 0.667 moles of this. We have 3.06 moles of this. Let's do this one, because this is the simple. We're going to create a fraction. So we're going to take the number of moles divided by the coefficient in front. So essentially 3 moles divided by 3. 3 divided by is 1. You multiply by the coefficient in front of the one you're looking for. So 3 divided by the one you have, 3 divided by 3 is 1 times 2. How many you need to make this thing work? To completely, you need 2 moles. You have only 2/3 of a mole. So this one, you need way more than you have. So this is going to be your limiting rate. Okay? Now, if you'd done this the other way, you could have said 0.6776 divided by 2. And then multiply that by, so 0.76 divided by 2, 0.6676 divided by 2 is equal to 338 times 3 is 0.001. So you need 1.01 moles here. Need one, have 3, so you have way more than you need. Still, points, this one is the limiter, so it doesn't really matter which one you start with. You just got to know which one is going to. Then remember this carefully. Remember, you only use the moles that you have. You don't need to worry about how many you need. You don't need to worry about anything about the other one, because the other one, plenty. Worry about what you have from the limiting reactant. So which is the limiting reactant? I'll put that answer in this color. Is FeBr. So iron 3 bromide. That's the limiter. So FeBr3 is limiter. Got it. Okay. Now, which iron 3 sulfate will be produced? Well, this is iron 3 sulfate. Iron has a 3 plus charge. That's why that 3 is there. Sulfate ion is polyatomic. Has a 2 charge. That's why that is there. So this is iron 3 sulfate. So the question is, how many grams of iron 3 sulfate will be produced? I guess it doesn't say how much iron 3. It just says how much. So I would say grams and moles. Grams and moles. Okay, so go back over here to what we have. 0.67 divided by 2, which turns out to be 0.3338. And then multiply by the coefficient in front. Well, this coefficient in front here is 1. So that means you have 0.338 moles of iron sulfate. Okay, so that's how much iron 3 sulfate will be produced. 0.3338 moles. And the last, we did the apply mole ratios. We did there. The last thing says convert moles to grams if necessary. And so we're going to say, yeah, let's do that. Let's convert to grams. Know how many grams that is. So now down here, remember Fe is 55.85. Oh, right there, 0.85 grams per mole, and 2 of those times 2, and then SO4. We should do an SO4 here by itself. So S and then O4 is 64. S is 32.066. And then 64. So the total SO4 is 96.06 grams per mole. And remember, I'm going to put SO4. It's equal to 96.06 gram per mole. And there are 3 of those right here. 3 SO4s. So times 3 equals, so 96.066 times 3 is 288.2. So 288.2 grams per mole. And then 55.885 times 2, 55.85 times 2 is 111.7. 111.7. And we add those together and we get 0.9, and 8 and 1 and 1 is 999, and 2 and 1 is 3. So 399.9, we just say that's 400 grams. Okay, so 400 grams of this. Okay? Now, grams per mole. Sorry, I put that in the wrong place. That's the molar mass, grams per mole. That does not belong here. So let me give that. I knew that. I just make sure I don't jump ahead of myself. Okay, so how many grams is that? This is your grams per mole. We multiply that times the moles present. So moles times molar mass will give us grams. So the number of moles is 0.338. 0. Let's 0.338 moles times 100 grams per mole is equal to, let's do this in a different color. Let's make it that bright blue color again. 400 times 0.338 is 135.2. So 135 grams. 135 grams. Okay, so you have 135. Let's go with that. 135 grams of that. Okay, so this is 0.338 moles, 135 grams. Now, this is where you're going to need a number. So I'm going to put 100, just put 100. So if 100 grams of iron 3 sulfate is produced, percent yield. Well, percent yield is found by theoretical yield, which is found by math. That's what we just did. We did the math to find the theoretical yield. In other words, how much should have shown up if everything to perfection? And that's mathematically discovered. So we found the theoretical yield to be 135 grams. And then what comes along here is reality kicks in and say, hey, wait, whoa. You're supposed to get 135 grams. What if only 100 grams showed up? So percent yield is equal to theoretical yield. Not theoretical. Actual yield. And that's divided by theoretical yield. Actual divided by theory multiplied by 100. Okay, so actual found in the lab. Theory is found using math. That's just a regular stoichiometry problem, what we just did. Found that theoretically to be 130.35. In actuality, 100 grams was produced, so we'll say 100 divided by 1.15. 100 grams divided by 135 grams. Notice how grams cancel because as a percent, it's just a, and then multiply that fraction by 100 times 100 equals, so 100 by 135 times 100 is 74%. So 74% yield. Okay, and that's how you do it. So if 100 grams of sulfate is produced, what's the percent yield? Let's say